Sketch a graph of an example of a function f that satisfies all the given conditions. And we have 3 conditions that we're dealing with here. First of all, the easiest one to do is write f of 0 equals 1, right? That's pretty easy. That tells us that our graph has to contain the point 0, 1. And then the other 2 conditions we have are limits as x approaches 0. This first one is the left-hand limit of the function as x approaches 0 has to be 3. So we don't know what's happening over here, but as the function is approaching x equals 0, we have to be getting closer and closer to 3. Whether it's from above or below, we've got to be getting closer and closer to 3. But it can't equal 3 at 0 because the function we already know has to equal 1 at 0. So we're going to have an open circle there and then somehow be approaching that from the left. I'm just going to draw it like this. Doesn't actually matter. You could do it differently. Yours might end up going from below, for example. But I'm going to delete that because I don't want to have multiple functions on my graph. But basically, somehow it needs to be approaching 3 on the left. And then on the right, the limit is -2. So on the right-hand side, we've got to be approaching -2. And again, it can be from above, it can be from below. It could actually be a constant over here. In fact, why not make the right-hand side of this function a constant function? Doesn't always have to be a curve, can be linear. And this is one example of a function that is equal to 1 when x is 0, but the left-handed limit is 3 and the right-handed limit is -2. There are lots of other examples you could do, but what we need here is a closed circle, a point at 0, 1, and then open circles at 0, 3 and 0, -2. And we need the left-hand side of the graph to connect to that top open circle and the right-hand side somehow to connect to the bottom one. And there we have it.